In this video, we're diving into the essentials of creating custom reinforcement learning environments in OpenAI Gym. By the end, you'll master the skills needed to design and implement your own gym environments tailored to your specific projects.
Welcome to our deep dive into custom environments in OpenAI Gym. Did you know that crafting your own simulation can be the key to unlocking the full potential of your reinforcement learning projects? Today, we'll explore why custom environments are crucial, how they allow you to tailor simulations to meet specific needs, and what you can achieve by mastering this skill. By the end of this video, you'll be equipped to design and implement your own OpenAI Gym environments. So, let's jump in and start exploring the architecture that makes this possible.
To build custom environments effectively, it's essential to understand the architecture of OpenAI Gym. At its core, OpenAI Gym is designed to provide a standardized interface for various reinforcement learning tasks. The heart of this is the end class. This class defines the environment state and provides the essential methods that interact with a learning agent. Understanding how the environment integrates with the broader gym structure helps in creating seamless and functional simulations. We'll explore each component in detail, starting with how the end class acts as the blueprint for all gym environments. The end class is fundamental to creating environments in OpenAI Gym. It serves as the template that all environments are based on. Key methods within this class include step, reset, and render, each playing a significant role in the interaction between the environment and the learning agent. The step method advances the environment by one-time step, the reset method resets the environment to its initial state, and the render method visualizes the environment. Customizing the end class allows you to tailor these interactions to suit your specific project needs, ensuring that your custom environment behaves as required.
Observation and action spaces are critical components of any gym environment. Observation spaces define what the agent perceives from the environment, while action spaces specify the actions an agent can take. These spaces can be discrete or continuous, depending on the task. Defining these correctly is essential for the agent to interpret the environment state and make informed decisions. For instance, a simple game might have a discrete action space representing different moves, whereas a robotic simulation could require a continuous space for precise control. We'll look at how to define these spaces to suit your custom environment.
The step function is arguably the most crucial method in the end class. It takes an action as input and returns 4 values: observation, reward, done, and info. These values represent the new state of the environment, the reward received, whether the episode has ended, and additional information, respectively. Implementing this function involves defining how actions affect the environment and how state transitions are handled. For example, in a grid world, taking a move right action would update the agent's position and return the new state. Proper implementation of the step function ensures accurate and meaningful interactions between the agent and environment.
The reset method is vital for setting the initial conditions of your gym environment. This method is called at the start of each episode to initialize the environment and return the initial observation. It's crucial for ensuring that your environment starts in a consistent state every time, which is essential for training loops and reinforcement learning. Imagine a racing game where the reset method ensures the car starts from the starting line with full fuel. Implementing a robust reset method helps maintain consistency and reliability in your custom environment, setting the stage for effective training sessions.
Rewards are the feedback mechanism through which an agent learns about its action's value in a given state. Defining these rewards accurately is crucial, as they directly influence the agent's learning process. Similarly, determining when an episode should terminate is essential for structuring the learning experience. This could be based on achieving a goal, exceeding a time limit, or other criteria specific to your environment. Balancing rewards and penalties encourages desired behaviors and discourages unfavorable ones. For instance, in a navigation task, reaching the goal could yield a high reward, while hitting an obstacle could lead to a penalty, ensuring the agent learns efficient pathfinding strategies. Once your custom environment is ready, integrating it with OpenAI Gym involves registering it so that it can be used like any other gym environment. This process requires defining your environment's entry point and specifying it in a registration call. Proper integration ensures that your environment can leverage Gym's tools and methodologies, making it easier to test and refine. We'll walk through the steps needed to register your environment and ensure it functions seamlessly within the Gym ecosystem. This enables you to test your environment thoroughly and make any necessary adjustments to optimize performance.
Creating a custom environment is only part of the task. Ensuring it operates correctly is crucial. Debugging and testing are essential phases in this process. Testing strategies include running simulations with known outcomes to verify behavior, while debugging involves identifying and resolving errors. Common issues might involve incorrect state transitions or misconfigured rewards. Implementing comprehensive testing and debugging protocols ensures that your environment is robust and ready for reinforcement learning tasks. We'll explore practical strategies for testing and debugging your custom environment, including tools and techniques used in real-world applications.
Congratulations on making it through this comprehensive guide on building custom environments in OpenAI Gym. We've covered the architecture, the end class, observation and action spaces, and more, giving you the tools to tailor simulations to your projects. Custom environments empower your reinforcement learning projects, offering flexibility and precision. We encourage you to experiment and explore the full potential of custom environments. If you found this video helpful, please like, share, and comment on what you'd like to learn next. Subscribe for more in-depth tutorials and continue your learning journey with us.